Hi, everyone. Yeah, thank you for joining. I hope it'll be informative and maybe a bit less dry than I think my bio might lead it to sound. I find AI is really exciting. I think that's probably why a lot of us are here. And I'm definitely like a bit of a tinkerer and a hacker. So I like to get in a little bit more in the weeds of how these things work. And so I've been doing these presentations, specifically this one for teachers for about 6 months, uh, because I think it's important that now that we can talk to our computers in plain language, we bring with that a lot of assumptions. Like I have a conversation with a person, it means that they're probably thinking in a way similar to me and in this similar mechanism. But AI is not necessarily doing that in the same way. And so in this talk, I want to just do a little very, very gentle introduction into some of the deeper mechanisms at work behind AI systems. And then, well, what does that mean for the classroom? So, as a teacher, what are some questions we can ask, like when we're considering, is this an appropriate use case for my classroom? Or as a school leader, maybe, is this an appropriate use case for my school? But also, how do I broach this topic with students and you know, they are growing up in a world very different from our own because of this technology. And so, how do we start building that core understanding? As mentioned, if you have any questions, feel free to put them in the chat or raise your hand. It's 12:30 in the morning here, so rather than me just talking to my monitor, it's nice to have an interaction. But I hope we'll talk more later. So, in this talk today, we're going to learn first about this really core principle in generative language models. So, like the ones that we talk to, like ChatGPT, Gemini, Claude, and it's called tokens. And so, we're going to spend a lot of time focusing on tokens. It's like the words or the vocabulary of these systems. And it's a really core idea that we understand if we're going to understand a little bit more deeply about how they work. So, then once we have that understanding, we can look at, well, how do these systems work, and we can actually do some experimenting and some playing. And I built a couple of tools I'm going to share that you're more than welcome to go and play at your leisure. But without further ado, what are tokens? Well, like I said, tokens are kind of like the vocabulary or the alphabet that these language models speak. um, English, we have 26 letters. ChatGPT 4.0 has 200,000 of these. So it's a huge amount more than our natural language. And they don't speak English, and they don't really speak any other language. They process these tokens. So these tokens, when they get into the model, are actually like just without sounding too intimidating, they're a vector, a very high dimensional vector, which means they're about like 10,000 plus numbers in a row. And that's what the LLM sees when you say the. But we don't need to get that deep into it. What we can look at just on a very high surface level is that they're not seeing letters. So I can ask it something like, does this story contain the letter E? And this was, the new reasoning model. And it says, sure, it does. Like the word through and shadows, which don't contain the letter E. But why doesn't it know that? Because it doesn't see the letters, it sees these tokens. It's the same reason why, and I'm not sure if you know this, but there's a big experiment around the word strawberry, where a lot of these models, if you say how many R's are in the word strawberry, it says two, but there's three. And why? Because it doesn't see the letters, it sees these tokens. So it's really important. What's the takeaway from this slide? That they're not seeing letters, they are working in these tokens. But let's talk about what they look like. So here is a picture of a tokenized sentence where I said, pineapples are my favorite food. And I think this is actually a really illustrative example where a lot of common words like are my favorite food or and very, they have their own token. So that means that the model has some concept for the word favorite, has some concept for the word very that it can understand. But less common words like pineapples get subdivided into multiple tokens, which means that their meaning is a bit more spread out. Common words tend to have their own token. There's like a technical explanation for this. If you want to look into it, it's called byte pair encoding. But basically, the more common a word is, the more likely it is to have its own token. The less common a word is, the more likely it is to be split into multiple tokens, like the word pineapple. One thing that's interesting to me, and I'm, like a language nerd, so maybe not to you, but hopefully, is that just to take a step back, the way these models work is that the more tokens they use, the more compute power and the more cost they incur. So languages that are not English, like I live in Korea, use a lot more tokens because when they've gone and taken all the words off the internet, there's a lot less Korean there. So Korean on average uses about 3 times the number of tokens, which means they're about 3 times more expensive to implement a Korean system. Portuguese, I've heard, it's about like 50 to 75% more expensive than English to use it. So it's something to keep in mind. It also means that if you have a diverse range of students or learners who are using these models that don't speak English as their first language, the model's representation of the language is probably a bit weaker. Like my wife she still thinks they're pretty bad at Korean. Like they write textbook Korean that sounds like it was translated from English poorly, which sounds like a fairly good assessment of maybe how these things are processing language. But, let's move on to, well, what are these systems doing? And so just to clarify, by LLMs, I mean large language models. And by large language models, I mean ChatGPT or Claude or Anthropic. So what are they doing? Amazing new technology. Like, let's make it simple. They are choosing the next token. Hi, my name is, what comes next? Ryan. That's all their job is to do, is choose what comes next in the sequence. And they do this many times. So when you talk to it, it doesn't just choose one word or a part of a word. It does it 100 or 1,000 times to make a sentence or a paragraph or an essay or whatever it's doing to respond to you. But really, all it is ever doing is choosing the next token. It says, oh, hi, my name, what comes next is. Now it takes hi, my name is, puts it back in. What comes next? Ryan. Okay. And it just keeps going around and around in a circle. On a very high level, that's kind of what they're doing. And so the question is, well, how do they know what to say? And, again, we can get into like a really complicated explanation of this. But the biggest thing to understand is that actually they don't quite pick the token. What they do is they look across their whole vocabulary. So they said they have 200,000 tokens in their vocabulary. They look across that whole vocabulary, and for each one in that vocabulary, they say, how likely is it to come next? Hi, my name is Ryan, Michael, Steve, Bob, John, etc. It'll assign a probability to each of those. If it was me, it would be very likely I would say Ryan. But they don't just pick a word. That's not really how they work. They're always looking at these like relative probabilities, which is, so if they give it a high score, it's probably going to come next. If they give it a low score, it's probably not going to come next. But this is a fundamental concept to understand, because once you understand that they're not, when I'm talking now, I'm not thinking like across all the words that I know, I'm going to rank every single one of them and then choose the next word. No, I've got a chain of thought and an intent and a semantic meaning that I want to convey. These systems are weighing like percentages for everything that comes next. And so that's one of the reasons why their output can be so strange sometimes. And we're going to really try to explore that in a way that is hopefully relatively accessible. So I want to give you an example. I'm going to ask ChatGPT, name a random country. And then I'm going to follow this with screenshots from a platform that we're going to get into in about 5 or 8 minutes. and then I'll share the link so you can feel free to play on your own as well. But name a random country comes up with Mongolia. And if you look at this, it doesn't just say Mongolia, it's also like beautifully color coded. So the purple in this platform, it means that there's like less than a 50% chance it could have said M. It could have said Kaz, like if you look there, which I would assume would be Kazakhstan, or like T for Turkey or something. Um, and so there's a really good question from Harry. I'm going to get back to it just because I think there's a point a bit later where it blends in really well. But even for what you're asking right now, Harry, you know that M is purple, and there's like a 35% chance it was going to say M, and all these other things. But once it decided to say M, the next token ONG that it chose, there was a 98% chance that it was going to say Om. It could have said Ali, which is Mali, and then it's done. It could have said Old, which is like Moldova or Macedonia, but for whatever reason, it's gonna most likely say Ong after that first N, and then it's absolutely gonna say Olia because there's no other country that it could have been. And so these preceding tokens really influence what comes next. And so what Harry asked was, he said, well, when we ask it to do this like really long multi-step task, how does it know? It has seen a lot of people solve multi-step tasks. They're masters of rhetoric, often with a very terrible pun, say like these are rhetorical devices. It knows how to formulate a sentence and an argument. It knows how to make ordered lists really, really well. What's a great place to go? Okay, number one, number two, number three. If you've ever talked to ChatGPT, it loves doing that. But it's because it's learned these rhetorical patterns that it's going to follow. So, for example, if I say like, "What's a great restaurant in Busan?" Doesn't really matter. If you ever come to Busan, maybe you can ask it. But what we want to look at here is all the different colors that we get over here. And so when we get into the system, things that are in blue, like it's almost 100% sure that it's going to say that. It's almost hard coded. Whereas green, there's like it's 95 or more percent sure. And yellow, it's quite sure. And red, it's like a little bit unsure, pretty unsure. Purple, it's pretty random. And so you can see like when I talk to it, there is a big variance once you're actually like looking at how is it predicting what comes next? And it can be surprising. So an example of one way that it can be surprising is if I say, choose a random number from 1 to 10. And if you want to try this in ChatGPT, you do have to say no tools because ChatGPT will like write a computer program that chooses a random number. But if I say choose a random number from 1 to 10, it says I'll choose the number 7. And 7's in blue, which means it's always going to say 7. To prove it, and I'm going to make sure I'm using 4.0. Always doing a live demo is dangerous, but choose a random number from 1 to 10, no tools. And we'll see. 7. Always going to be 7. Because for whatever reason, during their training, they always gave it 7. That's like this model's bias or habit. 99.28% chance it was 7. There's even a 0.07% chance it was 7 written out. Also, if I say like, give me a random YouTube link, and no tools because it might Google a YouTube link, it'll Rickroll you. Because why not? I guess whoever's training these models had a little bit of fun there. So I think that's pretty interesting because I would assume when I say, tell me a random thing, it's going to tell me a random thing, but it's not once we start looking at really well what is going on behind what it is doing. So, for example, if I say just tell me a random number, and this is the platform I built. It's really, really elementary, but it lets me click generate a response. It'll go to ChatGPT. It'll come back, but it'll show me everything in those beautiful colors that we saw. So I can click on a number like 47 and I'll get my pie chart that shows me the probabilities. And there's a 26.6 chance that it was 47. This is more random than the number 7, but it's really, really not random. Like there's like a 75-90% chance that it's one of these top 4 numbers. And so when we're talking to these systems, we need to understand that the bias behind them is not just like we talk about human bias towards people and ideas and things, it's towards the type of language that it produces. And so to take a step in a totally different direction, we've looked at these probabilities and tokens and everything. How do we bring this into a classroom, and have this discussion with students? Well, one thing that AI systems do is that they hallucinate. And so that's, I think, a really important conversation that we do have with our, kids, to make sure that they understand, well, what is an AI hallucination and why is it hallucinating? And how do we identify it? So we're going to look at a type of problem that AIs have called the reversibility curse. And the classic reversibility curse is that you say, who is Tom Cruise's mother? And it's able to tell you. But then you say, who is, and I apologize, I forget her name, but who is her son? And it won't know Tom Cruise because it can go like in one direction, but it can't go the other. It'll make something. Unfortunately, they've trained the model, so now that they don't do that anymore. So we have to pick a more obscure actor. So my example is to say, who is Philip Seymour Hoffman's mother? And let's look at the response. So Philip Seymour Hoffman, and these are, in blue and green, so very, very confident that it's going to say this, was Marilyn O'Connor. And we can see that there was like 99% confidence, more than, that it was going to say this. On the other hand, if I say, who is Marilyn O'Connor's son, we can see like there's a lot more uncertainty. Late, he did die. Philip Seymour Hoffman has passed away. So it's right, late. But it could have been like actor, could have been American, could have been actress, which is, maybe a little bit, unless they're like an acting family of like a brother and a sister. Well, actress is a bit weird for son. When we look at actor, it could have been comedian, could have been musician, singer, basketball player. Here, comedian could have been filmmaker, musician, singer. And then, like, when we look at the name John, could have been Chris, James, Jerry, George, Michael, Mike, Jim, Brian. By looking at this, we can really clearly see that this is not a trustworthy response that we're getting from this AI output. And I think this is something that is quite powerful to see, that when you're talking to ChatGPT and these other systems, you're seeing the surface of the water, but you can go quite a bit deeper into, well, what's happening beneath it and what kind of insights can we get. So a lot of people said that they're from Fairfax. So let me just do another little language experiment because I am, again, an English teacher by trade. So what is a good place to visit in, and we're going to run this. And what I want to look at here is I want to look at something I have done with, middle school classes when we've talked about these systems. Comes back in like a ton of different colors. And, we can see like here, we're going to selectively pick things, but it's recommended me the Fairfax Museum and Visitor Center, the George Mason University, and the National Firearms Museum, and Lake Cotting Park. If I click on Fairfax over here, we can see like, what are these different things that it would recommend? So how is it, weighing everything that it's going to suggest? That's definitely going to be like this big pivot point for what it's going to tell us. So when we're talking about even just our own composition with students, the choices we make and what we write, will dictate what comes after. And so Harry, to loop back again to what you had mentioned or what you had asked, Here, it's given me multi suggestions of things to see in Fairfax. After it says Fairfax Museum and Center, it knows that it needs to describe what it is. After it says George Mason University, it knows that it needs to describe what that is. It's very, very much influenced by what it has said before and what it looks back at. But something else I would ask the students is like, well, why don't we look at what is red or purple here? What are those words? See, there's a lot of red and purple. And we know from that previous example that when we saw like Philip Seymour Hoffman and what's his mother's son's name, and then like there's all that red around like the kids' names, that meant it was hallucinating. So does all this red mean that it's hallucinating about Fairfax? And well, let's look at those words. So the first word that's in red is offers. That's a verb. It's telling us that we can see that. The next word it could have recommended was has. And then you could say, well, if I say Fairfax, Virginia offers or Fairfax, Virginia has, does that actually change the meaning in any way? No, it doesn't. And so like then we can start interrogating like the parts of language that are being used by these systems. And when you start looking at these, like there's a lot more variance around semantically similar words. And so what I mean is like I can replace offers with has. Fairfax, Virginia has several interesting places to visit. Even if I look at the next word, several, could have just been various, many, plenty, numerous. It's going to just choose one, I guess. Or it could have said a lot of different places to visit. My point is that, like, not only does this give us a window into how these systems are looking at language, it gives us a window into language itself that we can start having discussions with our students about. And that's something that I find exciting. I get really excited about like the inner workings of AI, but I also get really excited about like how it exposes other domains to fresh conversations. So I hope it's been interesting so far. I'm going to take a little bit of a pivot to another angle that I see a lot of AI systems use. And so that's around assessment. And I've pretty strong feelings about using AI for assessment. And what I'm talking about more specifically is quantitative assessment, which means like, here's a paper, give me a grade. Then qualitative assessment, which means, oh, you did pretty well here, but you could improve here and here. I do have strong feelings about both, but it's a lot easier to wrap up my quantitative assessment opinions in a nice little bow in 5 minutes or so we can get to Q&A. So here I have like another chat that I'm going to introduce it. I was an IB teacher, so I taught primary, middle school, and high school. Right here, what I've done is I've given it a middle school, which is called MYP in the IB rubric for writing. And so what that basically means at a very high level is that I'm going to give you an essay. I want you to grade it. If it's a level 0, it's this. If it's a level 1 to 2, it's this. If it's a level 3 to 4, it's this. 5 to 6, it's this. 7 to 8, it's this. Very, very rough outline if you're not familiar with the IB. A, B, like B minus, D to C, and an F. So basically, give me a grade. Here's an essay. That's all I'm saying. And then I can run it. And it's going to tell me, okay, it's in between a level 3 and a level 4. And there's some uncertainty there. Like when I click on level, could have been a 5. There's like a 4% chance it could have been a 5. There was a 1% chance it could have been a 4. That means that put in 100 kids' essays, they all did the same work. 65% of them, like let's just say, we'll just go with the numbers. Let's just say that 95 students get a 3 to a 4, but 4 students get a 5 and 1 student gets a 4 for some reason. That's a bit of an issue with how these systems work. But what it also exposes is that like the prompt is really sensitive to like anything I put in. So if I put in just some enters and spaces, like here, I'm just gonna enter, space, and I'm gonna go here and And all I've done is put in like a little bit of extra white space. Does that change anything? Oh, this time it did. So, so when I practice it, you can see it changed the probabilities a little, but it may actually change the prompt. I'm going to get rid of my spaces, and didn't happen this time, but really, really subtle changes can actually flip the grades, but also choices in how you prompt. So let's say, for whatever reason, instead of giving it a rubric and then giving it an essay, I give it an essay and then I give it a rubric. And I say, here's my essay, mark it by this criteria. Now I get a very different grade. I get a 5. And it could have been a 6. So let's say I have 100 students now and I did the essay first and then the rubric. 57 of them, 58 of them got a 5. 17 of them got a 6. One of them might have been lucky enough to get a 7, or they could have gotten a 4. It's in like that same kind of 1% range over there, which means that I haven't changed anything about the rubric or the essay. All I've done is changed the order. And this is something that like we might not do consciously. As a teacher, if I see the rubric first and then the essay, or the essay first and then the rubric, hopefully I'm relatively consistent. But these systems really, really are not consistent with how we do this. And
Ryan?
so I think that's one of the big risks. Sorry, go ahead.
Ryan, sorry. There's just a question here from Amrita. I think it's a clarification question. That's why
Oh, sure.
I'm just stopping to ask. So, Amrita, would you like to ask, or I'll read it out if you prefer? You can just tell me in the chat.
Yeah, yeah, sure. So, like the results on the text, I can see it has a different color than the one that is beside the pie chart. For example, here
Mhm.
we have 5 in red, but
Yeah.
beside the 5 pie chart, it says 5 is like blue. So,
Yeah.
how do we interpret this difference?
Yeah, it's a really good question. It's a little bit of a hastily built platform. So when we look
Mm-hmm.
at the words that we get over here, we can, this is one where we can look at a lot more colors. So when we look at the words, these colors show the probabilities of the first token. So here it said charming. Because it's in yellow, I think it means it's somewhere between like a 70 and a 90% probability. So we can see
Mm-hmm.
it's 77%. So these colors up here on the words, they denote the probabilities. Oh, did I lose it? Sorry. When we look at the pie chart, I'm using a library called React eCharts. It just helps me do the pie charts really quickly. And one thing that it does is it just always uses the colors in this order. I haven't set any custom color scheme. And so for the pie chart, the blue is always the first one is blue, and the next one is always green, and then yellow, and then red. It's something that I should probably adjust just for clarity's sake. But here, for example, if I click on shopping, you'll see that in the legend, the colors never change. So unfortunately, I know it introduces a little bit of visual noise in how we interpret it, but I hope that's clear.
Thanks for clarification. Yeah, that's clear. Makes sense. Thank you.
Um, yeah, no problem. And so there's another question. It said, if we give it a more detailed rubric, would it make the output more consistent? Not necessarily. It can actually introduce more complication into, like there's more things for it to decide. In fact, if you instead ask it like really binary questions, that's how I think you can start to get more consistent results. And what I mean by that is yes or no. So does the essay use this? Does the essay have examples of this? Yes or no? One of the problems with these systems is that they once they have an idea, like they tend to get very fixated on it. And so what I mean is that once it has an idea that something is okay, or once it's made some kind of value judgment, then what it says later will generally reinforce what it said before. So to give an example of that, if we go back to the grading, something that you can do with all these AI systems is that I can actually kind of like put words in its mouth. I can say, you said this. So I can, over here where it says assistant, I can pretend that the assistant said, this is a 2. This essay got a 2 out of 8. And then as a user, I can say, why? Why did you give it a 2? And when I click generate response, it'll tell me why it gave it a 2. And a 2, just to be clear, is a failing, like basically a failing grade. And so it says, it shows limited personal engagement. It presents a straightforward narrative. It doesn't really use much descriptive language. Therefore, I gave it this grade. Well, what happens if I gave it like an A plus, an 8? Like that's the highest grade it could have gotten. Why? I gotta give it a second. The essay demonstrates a high degree of personal engagement. It's basically contradicting what it said before, but it's because what's really, really influencing what it's saying now is this. And it's something that's kind of interesting to me when I use these systems, in that sometimes my conversations can like get down some like loophole or like something. I'll tell it some idea and I'll be like, Ryan, you're really smart. I think these models really like to say that. And then I'll come back and say it in some other way, and I'll be like, no, you got this totally wrong. And then because I started a new conversation, and in the previous conversation, it was really getting reaffirmed with what I previously said, but now it is, um, got a fresh eye on things and it thinks about it differently. And so hopefully that gives you a lot of food for thought. I know it's been a lot in a 35-minute period, and I could probably go on for a couple more hours, but I won't, because
Ryan,
I think it's
if you have more for 5 more minutes or so, you're welcome to keep going. It's up to you. We can start discussion, but
sure.
if
Well,
there's
if
stuff you want to show.
people have questions, you're more than welcome to interject or ask. Now would be a good time, but I can also share some other stuff.
We do have a question here from Harry. Harry, it's up to you if you want to use your microphone, or I can read out the question. Just let me know in the chat.
Yeah, I've been impressed with the ability to put together a long stream of instructions, asking it how to do something.
Mhm.
I wanted to know where the logic came from, and I think I'm beginning to understand that. It's not really thinking logically, it's basically looking at example logic from previous stuff in the training data and then just imposing that on the answer. Is that right?
Yeah, I think like in some ways you're getting into like an epistemological question, like what is language and what is meaning and what is logic, and how does it get represented. Once I started looking at tokens on this level, something I found really interesting was this. Let me see if I can find my notes. If I say something like, hi, how are you? There's a reason why I'm saying this. It's because it comes back with a lot of blue here, which means like what this is a really short example that we can look at, but it means like there's very little uncertainty in what it's going to say. So when I click on a word like feelings, or let's see if we can find it here. Um, yeah, I'm here. Like I can read Korean, yogi means here. And in Chinese, I would assume that also means here, like in these other languages. That it does have like a semantic core, like a meaning that it is trying to convey when it is talking. And I think like this is kind of evidence that it doesn't need to say, but I'm here. It could say, but I'm ready to help you, or but I'm, curious what you want to talk about, or like there's a million different linguistically valid pathways it could have gone down. But it does have like an internal coherence or logic to what it's doing. But I think you're right, Harry, that it is very much created by the examples that it has seen. in my experience, and this is my like vibe, my feeling just from using these systems, uh, Claude tends to be quite like formulaic in how it structures its sentences. These systems do, I think, tend to be more formulaic than how we communicate as people. One of the measures of AI text is called perplexity. It's not just a website. And perplexity is really like, how random are some of the word choices? Because we all have our own eccentricities about how we use language. And so, it would look at my bio and realize that Ryan said pedagogical like way too many times for this to be, random or some other way. And so these AI systems tend to also have their own habits that tend to be a bit more normalized. I hope that kind of is a little bit like elucidates what I'm trying to say, makes it a bit clearer.
Thanks.
Yeah. So, some of the much, much, much more complex work that I've been doing, and I won't get too much into it now, but what I'm really trying to look at is when, for example, we're grading and it decides that this is a 3 or something. Um, if I take all the words that came before it, can I identify which words were most significant in affecting that grade? Like what words made it more likely to be an A and what words made it more likely to be a B or a C? And then we can start understanding it on a much deeper level. There's a way to do this mathematically using backpropagation and calculus to determine the gradient, which is like the influence between an input and the output. But that's something that for another day. If you're interested, definitely reach out. But no, I think I'm quite comfortable to shift over to question, answer, and kind of free form discussion if people would like that.
So we have Anil. Anil, you're free to use the microphone or just tell me in the chat if you'd like me to read out a question. Thank you, Anil. So how does this relatively new feature called reason works? So I'm assuming Anil is referring to, the O1 reasoning, where sometimes I don't know if that's by design or not, sometimes actually shows you how it's working something out. So maybe
Sure.
we can talk about that a little bit.
Yeah, absolutely. So it's super interesting. Basically, there was an experiment recently from Stanford, and I think this gives a really good example of how reasoning works. It's called the S1 model, and you can read about it. And they trained it for like $6 or something, and they were able to build this model that reasons that does a lot better than other models. And so the Stanford model, what did they do? Well, they had it like, here's a question, gives them an answer, and then they would take that and they would say dot dot dot, and then send it back, and then like the model would see and then it would think about it again, would do it again. And basically they trained the model after it came up with an idea to say wait, or let me think about that, and then like do that 3 or 4 times. So after it's thought about it 3 or 4 different times, come up with an answer. And it does a lot better because, like us, when we've thought about things from a couple of different angles, we get a bit more of a nuanced perspective. That's doing a little bit of a disservice to like the DeepSeek R1 and the O3 models, and all these big reasoning models that are coming out now. The way that those work is still they're using something called test time compute, which in AI, there's a lot of like really fancy terms. Basically, we're gonna let it think and waffle and come up with a bunch of different ideas before it actually answers you, and it has some kind of certainty. And so that's how it works. Very simply, they just tell it to think about ideas in more different ways. And there's much more complicated sides to it of how it evaluates what are good thought paths and what are less valid thought paths. But in a nutshell, it just makes it reason or think for longer. there is a caveat that like those models, in my experience, like with this quantitative assessment nonsense, they can be a lot more inconsistent because they have so much pre-context to kind of get fixated on certain ideas. Because it chose a couple of positive adjectives to describe something, it's now gone on a positive bent. Whereas, like, if you run it another time, for some reason, the first time it focused on something the person did badly and it goes down this negative bend. I found that the reasoning models are inherently less consistent for those type of tasks, but they're a lot better for like, tell me about this, or what do you think about this. So just something to be aware of, but they are very, very interesting.
So I guess I have a comment and a question, just from my own experiences, and I mainly use ChatGPT, but I use it for a whole lot of different stuff. One is that to me, it's quite clear that for some questions or prompts, it has a sort of prepared answer where it's not guessing the next token or doing anything like that necessarily. It just it has something ready that it's going to say, whether it's things that are like not within the terms and conditions or other things. Secondly, sometimes it gives you two responses and asks you which one you prefer, which
Mm-hmm.
is, I guess, an opportunity to train the model.
Yeah.
Because maybe it's, I don't know, maybe it's at a point where like it's not sure which token to go for or something. I don't know the reason, or maybe because they just programmed it because now they want to test something. Um,
Mm-hmm.
and what I saw with the new reasoning models, from what I, because sometimes it actually tells you what it's doing, it seems like it's breaking down the prompt or the challenge or the whatever you're giving it. So
Mm-hmm.
instead of just here's the answer token by token, it breaks it down to subtasks and then it does those subtasks for you.
Yeah.
So for example, if I wanted to write an essay about how the Sgt. Pepper's album was made or whatever. I'm a big Beatles
Yeah.
fan. So if you use the reasoning model, it won't simply just like behind the scenes, like or under the hood. It's not just going to write it token by token necessarily. It might
Mm-hmm.
say something like, oh, first I'm going to uh, write about the context of the year 1967 and what was going on musically. And then I'm going to write about the Beatles up to that point, the band and what they were doing. And then I'm going to write about the making of the album. Now I'm going to do one by one.
Yeah.
Does that sound about right? I mean, I'm just seeing what it's writing, like as it's reasoning. So,
Yeah. Yeah. So I think you're right. In terms of how those models work, they do, and they don't quite show us exactly what it's doing. The DeepSeek one actually does show you all of its reasoning.
mm,
It seems like the O3 model, especially, it's like doing a lot in tandem. So it does like all this brainstorming and then just everything appears, and it like kind of appears in different sections. So I
mm,
think it like, you're right, it is breaking it down into like subdivided tasks and then maybe like assigning it to different AI systems. To step back to your second question, when it gives you those two different responses, my understanding, and I could be wrong about this, but when you talk to these systems by the API, which is like, if you're not familiar with what that is, that's like how developers can talk to it. If I want to, build like this website that I've shown you, I don't use the website, I use the API. When you do
not
that,
through the ChatGPT interface,
no,
not through, yeah.
yeah, not through the interface. It gives you like a system footprint, and there's like a certain number or like a like identifier there. And in their documentation, they say that they have multiple systems that they are trying. And so, what I think is happening, and I'm not entirely sure here, but they are okay. We have like two different responses from our two different systems. We're not exactly sure, like, what's better, what's worse. Why don't we get some feedback to basically you're training the models for them? You're doing some reinforcement learning to create a data set that says this is a good response, this is a less good response. Be more like that. Um, and then the first question, which was about sometimes it's got like a canned response. So Gemini, please tell me about something political, and it will say, I can't.
Mm,
Um, that is from, there's kind of two ways that you can get this to happen. So either one, they've trained it a lot to basically anything political, it will say, I can't say that. And that is still predicting the next token. And it's saying,
Mm,
okay, this is what's happening next. The other way that they could be doing it is, you can have a different type of model, like a classifier model, to keep it kind of at a high level, that is basically trained to take in text and say, does this text talk about violence? Does it talk about politics? Does it talk
mm,
about like drugs or sex or any of those things? And then if that comes back above a certain threshold, then you just kill the output and you say, nope.
mm.
I think Microsoft does this with Copilot. I haven't used Copilot for a long time, but I remember it'd be like, start talking and just like, nope, please start a new conversation. And that's because they've used some kind of classifier that's identified this is not good. They've killed it that way.
Richard, please go ahead.
So I use, I was checking between 4.0 and the Pro, and I know that Pro is better in coding and all. I mean, this is what you say actually. But I have seen that 4.0 model is very good in content generation,
Mm-hmm.
and Pro is not actually. And I'm so surprised because Pro should be having that. It should retain that, attributes, and then become better in coding as well. So I don't know why why this is the case.
Yeah. So
So with the
these
same
models are,
prompt, you get different quality of answers, content generation.
yeah. I think that's a really good observation. You know, we get exposed to these models through like the marketing cycle of like, oh my god, this thing's so much better than the old one, go for it. But it's not necessarily linear. Like some of the really small models are incredibly interesting, like the ones that you can run on your phone. Like they're a little bit unpredictable and kind of funny in some ways that the bigger models aren't. uh, and so it's possible that the pro model has been trained off of like a lot more academic sources that are just boring and it's skewed in a certain way, or something has happened where in the training it doesn't resonate with you as well as some of the other models. Like you'll often see in the news postings like, whatever just got really stupid. Why is like GPT-4 has gotten, dumb all of a sudden. I remember we're getting a bunch of like articles about
Yeah.
that 6 or 8 months ago. It's because they pushed some update that just didn't like, the word I guess is vibe. Like it didn't vibe with the user. I really didn't like what GPT 4.0 sounded like for a long time. I thought it was just really like patronizing in how it was using its rhetoric. Um, I think in some ways it's maybe worth like also thinking about it in terms of people. Like the most enjoyable or creative person to talk to is not necessarily like the most intelligent or like the most academically verbose or the most sycophantic, like these models tend to be. Like they so there's a lot there. I think what I'm hoping is that in the future we move away from like the new model and we move more into like rhetorical paradigms, by which I mean like, this is a system that has been designed around creative writing and ideation, or something I wrote a lot about over the summer was like pedagogical rhetoric. If I go to Chat GPT or any of the systems and I say I have to write an essay about Sergeant Pepper's Lonely Heart Club's Band, it'll be like, all right, here's your essay. Or maybe here's what you should write about it. It's a great idea. And you've just circumvented like the whole thought and ideation process of students. It's like it's total garbage. Like it undermines so much of the learning process. Like, but because they've trained it to do that because they want to get businesses to buy it, because in the workplace you don't want to say, okay, I need to write a draft about this and it says, okay, well, what do you think about it? But in schools, I need to write an essay about 1984. Okay, well, what resonated with you about the I know I've kind of gone a little bit off track, but I think what you're experiencing is a disconnect between the marketing campaign and the reality of what these models are doing.
So Harry, please go ahead with your question. We have a few more minutes.
Well, I've been following the use of AI in my classes and our university and elsewhere. And one of the major problems we're struggling with is how to evaluate student work compared, what they think in an assignment with what the AI provided to them. So that was one of the reasons why I was listening to this talk, to kind of get a little bit of insight about you know using AI in education at any level and trying to figure out, well, how do we fairly grade something when you have an AI looking over your shoulder?
Yeah, and I think it's really challenging because I think it challenges a lot of our, let's say institutional inertia in that, what do we expect from students? I don't think there is a way to reliably detect what is AI written versus what isn't. So, like within like the old plagiarism paradigm. Um, if you're asking about, just AI detection, and I do
No,
apologize, it's a bit late here. So if you can clarify a little bit for me,
no, it's not
or
that,
just,
because we've gone through that particular phase of dealing
yeah,
with AI, trying to catch cheaters. That's not what I'm talking about. I mean, if I say I have an assignment that I want a human student to do something, but they can use AI to help them in some way. How do I then figure out to create a rubric that says, okay, here's how I grade this thing? Many different kinds of assignments, whether it's an essay or a programming project or whatever. It's really, really hard to figure out, you know, how to create a fair rubric for any kind of an assignment where AI is available.
yeah. So I don't have a clear answer about this, but where my musings are at the moment is that it's ultimately it can come down to like the product that is produced. And so what I mean by that is that AI gives us the capacity to stretch way beyond our own selves, but it also gives us like almost a more managerial role than in like producer role in a company. Rather than writing a report, we need to vet the output of our subordinates, in this case AI, to make sure that it meets the requirements of the task. And so one thing I've been thinking about is like, is it possible if it's an essay or a programming project, etc., to tell students that like, rather than coming up with one essay topic, like if this is an AI open assignment, go through 10, and your work is to show how did you deduce what is the most powerful argument here? And how did you work through the garbage and the riffraff? I use AI for coding a lot. And so oftentimes it has suggestions that are idiosyncratic to my style, are ineffective, or have security vulnerabilities, have missed some point of what I'm trying to do. um, how do you then assess what you're getting to produce the higher quality output? And so, kind of repositioning students rather than as the sole producer of a work to a more managerial position. I don't have a clear idea of what this looks like in terms of assessment or how you incorporate it, but I think that's just how the paradigm has shifted. And I hope that that kind of addresses your question.
It
Thank you,
gives me
Ryan
more
and
to think
Harry.
about. Thanks.
Thank you,
Yeah.
Ryan and Harry. We are at the end of the time. I just wanted to mention a couple of things very quickly. So Amrita saying, I had the opportunity to do an analysis of 30 university guidelines about generative AI use. The guidelines say there is no established AI detection tool in guidelines, and guidelines discourage using the existing one. So it's very hard to trust those tools. I want to end just by saying, because I've been thinking about the assessment question for a really long time, the conclusion I've reached and what I do at this point, and I'm actually carrying out a study at this point, I separate adherence from correctness. So I separate following the instructions of the assignment versus what you actually wrote in there, the actual content, and how correct it is. I do trust the general purpose LLMs like ChatGPT with adherence, as long as I provide them with a detailed rubric. I find that they do a job just as good as any human in terms of reliability. And I do need to prove that statistically, of course, and publish it. But that's what I'm seeing. In terms of correctness, everything that you've shown us today, a lot of issues with correctness. I leave that up to the domain experts. I leave that up to the instructors and the TAs. So
Yeah.
it does save me about 50% of the time if I can actually rely on the LLM, on ChatGPT and so on. And of course, I get the consent ethically and so forth. Then I can actually have ChatGPT just go through and see whether they've followed the instructions of the assignment and give feedback. And I do find that to be very useful. And as Ryan mentioned, the yes or no is very important, and delineating and defining everything is really important. But I do think that's perhaps a useful direction. When it comes to correctness, the actual content and how correct it is, it's a lot more complicated, I feel, trusting the LLMs. Unless you train your own. That's a whole different thing we haven't spoken about. We've just spoken about the general purpose, of course, that just go
Yeah.
to the internet and so forth.